Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're gonna see problem fruits into basket 2 and 3. Again, just the constraints is the difference. The story is exactly same. So let's see the problem. Let's see the problem first. So it says that they're given the fruits and baskets, you know, both having the corresponding size of length n, and fruits represents the quantity of the ith fruit which I have, and basket represents the capacity of the jth basket. Forget about this, we'll just see the main problem. We go on from left to right and place the fruits into these, with the help of these rules. Each fruit must be placed into the leftmost available basket. So I will take the fruit 4, I will start iterating from the left, and then I will see that in which basket I can place this fruit. Obviously, I can place a fruit of size 4 into a basket of more than its size. So I will place it at the 5. Then this basket is gone. I cannot place any other fruit even if there's some space left, because one basket will contain only one type of fruit and this fruit is done. Now for 2, I will look for, again from left right, I'll keep on iterating and then see which is the first leftmost basket which is not yet taken. Here it is 3. I'll just take it. Okay, this is also done. Then 5, I'll simply again iterate from the left to right. The first basket which is there, and again after iterating the entire array itself, I see there is no basket. Thus ultimately in the end I have one not placed, unplaced fruit, and that is the number which I have to return. How many number of unplaced fruit I have. For example, in this case, example 2, if I see I have 3. Okay, the first basket I placed it here. Then 6, I place it here. Then 1, I place it here. Okay, there are no unplaced fruit left, and that is my answer. So if you go very naively, what you will do, obviously you will do the same thing, that I will maintain. Okay, for the first basket I will iterate on the entire, for the first fruit I will iterate on the entire basket and see that whichever basket is not visited, so I will have to maintain a visited. It can be an array, it can be a hash set, it can be literally hash map, it can be anything. Just maintain the visited. Okay, then I will start iterating. Okay, is it more? No. Is it more? Yes. Okay, simply place it here and then mark your index of 2 as visited, so index of 1 as visited. This is visited, let's say visited. Then okay, for this specific index I for fruit, again iterate, again start iterating, and then the first index, okay, this is the one, mark index 0 also as visited. Now again I, you saw that simply start iterating. This is visited, I cannot go here. This is visited, I cannot go here. This is not visited, I can try here, but again this cannot fill the 5. So okay, no worries, you cannot go about here. And this is also not visited, so in the end this is one unplaced, so increase the unplaced count by 1. And that's how you can simply go about it. So what is the complexity here? Obviously for every I am simply iterating on the entire baskets, which will take O of n time. And again visited will take O of 1 time to maintain. It can be hash set, hash map, not set, anything whatsoever. So what is the complexity? For every I, O of n time. For all the i's of O of n, it will take O of n square time. Will this work? If I go down, n is 1e5. Okay, O of n square will not work. But for the first case, where n is just 100, basket 2 case, yes, this will work. So I'll see the code that I maintain a visited or used index. I'll say that go on to every index of my fruit, and then I will try from left to right of every index of basket. If that index, or if that basket size is more than my fruit, only then I can place it. Also, it should not be used before. If it is yes, I will place my basket, which means I will place my fruit here, which means I am counting that fruit. Okay, this is placed. But again, make sure your answer was unplaced. So you are counting the placed fruit. Your answer was unplaced fruit. So that's the one case that I will return n minus count. But obviously, if I have placed a fruit, I will make that index as used of the basket and I will break it here. And thus this will take time as O of n square, and also space of O of n in worst case, because I am kind of placing all the used indexes here. Now, as we saw that obviously this will not work, this will not work. In case of second, in case of this thing, this will not work. In case of basket 3, it will not work. So how to go about this? So if you think of very deeply, again, whenever you have to optimize or whenever you have to think of, we as in people have make sure that we use a strategy. What strategy is? Every time go on to a random index, any random index I'll go on to. So I have this random index, let's say 2. Now again, before we go on further, please make sure that we hit the like target of 100 likes. Again, it takes effort to make these videos, and again, if there are no likes or no views, again, you can even share it. Even if there are no likes, I'm good. Even if you can share and have more views, it will be much beneficial for us to motivate to make these videos. Else, ultimately, at one day, this will stop. Like, again, the entire motivation is the one which is keeping it ongoing. So yeah, that's one thing. Now, coming on back, we have this 4 to 5. Okay, so one thing we realize that we have a concept. Okay, every time I tell you that randomly place any index and see what should be the answer. If I randomly place an index, technically what I have to do, I have to find from the leftmost first maximum value, which I can, which on which I can place 2, on which I can place 2. Again, there is a concept of not taken as well. So yeah, there's a star mark which is not taken already, this star mark to it. So what did you see? Did you see that, like, again, I wrote my requirement in English language. First maximum value, again, in the in the left portion, which is obviously more than equal to 2, and again, obviously not taken. So now let's break it down. First maximum value on the left side. So somehow I am saying that I will have 3, 5, 4. Okay, let's maintain the maximum. What is the maximum so far? Okay, so 3 is, okay, 3 something which we have. Then if I take the, again, and I want to jump at that maximum value as soon as possible. So I want to have a structure such that I will be able to figure out very easily what is the maximum in a range. Did you see maximum in a range, range maximum, finding out the range maximum? Obviously, it might give you a hint of segment tree. And again, if not, then make sure that come on to crash course section. It is very easy. Come on to crash course section, go very down. You will see a Fenwick tree and segment tree crash course. Please make sure that you know about it. Although in this, I have shown you a generic segment tree as well. I have shown you, but again, this is more for lazy propagation and stuff, but usually in an interview you will not be required, and people, that's the reason, are scared of a segment tree. Segment tree is nothing, it's a simple tree. That's it, it's a simple tree. That's your segment tree. Don't confuse or don't be so much overwhelmed by hearing the word segment tree. It's simple tree. I will literally tell you by making a fresh code for segment tree, and I will not use a generic code because obviously it's a very long code, and it is required primarily when you are using your lazy propagation and when you have to do a range max query, and there are no range updates as such, so lazy propagation is not used. If whatever I'm speaking right now, if you don't understand this, the only solution it is go back and check the corresponding crash course. And again, if you want to practice, you can go on to the practice sheet as well. Again, come on here, DSA sheets, practice sheets, and then simply make sure that you can practice the segment tree as well. Now, coming on back, we realize that we want to find the range maximum, so I can use a segment tree here. Okay, 5 is the value here maximum. Then here also 5 is the value maximum. Okay, now that's how I can simply use my segment tree to get my range maximum value. But the catch here is that I want to get the first one. So technically, if I'm traversing on my segment tree, I should make sure that, like, obviously my segment tree helps in traversal. So if I'm standing here, I have two options. I can go left or right. Again, the maximum value could come from anywhere, left or right. But as we said, that primarily I have to go my left portion. So I will always try my left portion first. If I can try my left portion to the maximum value, I will try that. If not, then only I will try for the right portion. Okay, so traversal also makes sense that I will try for the left portion. But then I can place value 2, which means this 2. Obviously, I can place any value because you see that how I build the segment tree. Again, right now I am giving only the intuition portion. I will do a dry run separately, so no worry about that part. So if you see that when we build segment tree, we realized on the maximum value. So you will see I took the maximum at every step. 3, 5 maximum, 5, 5, 4 maximum, 5, and so on and so forth. So obviously, if I have 2 as a candidate, I will try to go to the left. And again, I saw 3. 3 is the value which is more than 2. So obviously, I can place my 2 at this specific place, at this specific location. Okay, so my placing also works. Now, not taken already, how I will cater it? So whenever 2 is placed, I have to make sure that, okay, this is marked as visited. So I have to put some default value here. What is the value which is default? Technically, I have to put some value such that next time no one can come up, or no one can reach here. So if you look at the constraints, you will see that all the fruits values are 1 or more than equal to 1. So any value which is less than 1 is a default value here, or is a non-reachable value. So what I can do, that I can put this as -1. You can put as 0 as well, but -1 just looks more better in terms of seeing. So I place -1, and then again, as I'm going up, I will rebuild my segment tree. But obviously, the segment tree has a beauty that as you are building up, as you're going up, you are not touching all the end nodes. That's the beauty. So let's say again, maximum is 5 and this also 5. So with that fact, what happened? That now you have made things visited as well. So now my 2, no more. Like my this value will no more be visited. But the catch is that you will start off from left to right. Now, let's see the actual try run. So, with the try run, again, as I told, that segment tree, don't be confused as very high level thing. No. Whenever there is a very normal segment tree, which is without lazy propagation, although lazy propagation is also easy and you will get that easily by using the crash course, but imagine segment tree as a simple tree which you are building. A simple tree traversal which you are doing. Imagine that as a segment tree. Now, obviously, in a segment tree, every node is given a value. The root node, we give a value of 1. Then the left node is root nodes into 2. Right node is root node into 2 plus 1. This is, I'm teaching concept of segment tree right now, but still you will get used to it. So this is how I have assigned the nodes to a segment tree. Yeah, right. So these 1, 3, 2, 4, 5, these are the node values of segment tree. But obviously, segment tree has a duty of holding something of my internal input array. So if you remember, my input array in this case was 354 because I want to build a segment tree of this specific baskets array. So a root node will hold the entire array 0 2. And again, as we do in a simple tree traversal, half portion goes to the left part, half goes to the right part. Half of 0 to 2, half will be 0 to 1 goes to the left part, half goes to the right part, 2 to 2, right? Again, same way you will see that this has reached, your start has become equal to end. So this is the leaf node you have reached. So simply place the leaf node at the index 2. I'll simply place the leaf node, which is the value 4. I'll simply place it here. But this is still not done. So I will find the mid again. Mid is nothing but 0 plus 1 by 2. So mid is 0. So 0 to 0 left part, 1 to 1 right part. And again, these have reached the leaf node. So 0 to 0 value is 3 and 1 to 1 value is 5. So with that, you will see my segment tree, as I was going down my segment tree, I have reached the leaf node. But again, segment tree's essence is building the entire segment tree. So while I am coming up, I have to build the segment tree, which means that while I'm coming up, I will take the maximum. And again, so because we know that we primarily use recursion for traversing on our entire tree, so I can simply use recursion left and right while coming up, which means whatever operation we perform while coming up, that is done after recursive step. That again, if you also don't know that part, I highly make sure that come onto the practice sheet and make sure that you are good with trees concept. So if I go down and you must have solved easy medium question of trees, that will be pretty okay. Coming on back. Okay, let's see. So we saw that while we come up, we will just put up 3 and 5 maximum, 5. 5 and 4 maximum, 5. So with that fact, we have now built up our segment tree. Again, this is the entire essence of segment tree. You see that I will give a node value, although when I will do a actual code show, then also I will show you this thing. But I give a value, and as I'm going downwards, I am putting up the leaf values. While I come up, I'll take the maximum because my requirement is the maximum. I'll show you a code also for just constructing the segment tree. So the constructing of the segment tree takes, as we know that to call for any tree node, I'll ask for simple recursion by saying that okay, basket array is the array which I have to give. Start and end is this thing. Start and end. I pass this. I say that start and end is 0 to 2 with the segment tree node value as 1. So start is 0, end is n minus 1, which is 2, with the segment tree node value as 1. Right? Then obviously, as you saw, that I will find the mid. Then I will again call my segment tree from start to mid. So obviously in this case, the mid is 1 because 0 plus 2 by 2 is 1. So I will call 0 to 1. So 0 to 1, I'll call my segment tree, this part. This is the left part. 0 to 1, I'm calling obviously with a node value of 2 into n. So if this is n, this is 2 into n. and this will be 2 into n plus 1. So with a node value of 2 into n. Same way I do the right side, it will become mid plus 1, which is 2, end is again a 2, and with a node value of 3, which is 2 into n plus 1. Now I said that while I am coming up, I have to calculate the maximum. So this is the same thing I did. This is the recursive step, but while you come up, you will perform your segment tree operation, which is the maximum from left and right. So while I come up, I'll take the maximum from my left and right, which is 2 into n and 2 into n plus 1. And this is the same thing. And again, this is a very basic recursion, which you should be knowing that while come up, whatever operation you have to do, you perform it after your recursive step. If you don't do it, again, make sure practice problem sheet. Now, coming on back, this is a simple construction of a tree, right? Okay. Now the tree is constructed. As you remembered, your task was to find for every fruit from left to right. So as we go on, we have the first fruit. First fruit is 4. So for 4, I will have to check what is the location. And again, to find the location, I will use my segment tree help. I will reach on to my first, root of the segment tree. It will say the value is 5. Obviously, 5 basket value is more than my 4. In that case, it is pretty okay for me to go, to try. But the question is trying the left part or the right part. Obviously, as I mentioned, I will always try that I can go left first. Why left? Because leftmost largest value I have to take in my baskets. So left will represent the leftmost value I'm taking from my basket itself. Because the problem says that first largest value more than the fruits, that's what I have to take. So I will take this and I will have two options. Obviously, this is more, so I can go and try which is the actual concrete index inside my basket. I have to find that step. So it's kind of binary search which I'm trying to use on my segment tree. So I will try to go always left first. And again, when I try to go to left, and how I will try, I will check 2 into, 2 into, again, if this is n, 2 into n is my left and 2 into n plus 1 is my right. So this is 2 into n and this is 2 into n plus 1. So I'll check if 2 into n segment tree value, if it is more than my fruit, yes, I can go left. Okay, I will go left. Same way here, I will try left and right. I will try left. Can I go left? No, I cannot go left because the segment tree value is 3. My value is 4. I cannot go left. Okay, in that case, I will go right. Yes, I go right. And again, as I go right, now you might say, Aryan, I will again try left and right. No, because I have reached the leaf node. Leaf node say, okay, I have reached the final destination node, which is the first value from the left, which is larger than or equal to my fruit value. Okay, in that case, I will simply say that now this is I have taken. Again, make sure Maqsad, your target was to get the unplaced ones. So either you can count the placed ones and then do a subtraction as we did previously, or you can just do nothing. Whenever it is unplaced, whenever things are unplaced, then maybe you can do something. So right now it is placed. But as we saw earlier, that if it is placed, I have to put some value which is not possible. So I said any value which is less than 1 is not possible. So let's place it -1. Now, although I place -1, but I should still make sure that I rebuild the tree, because now you know that why rebuilding of tree is required, because this value is 5, which is obviously incorrect because now 5 is gone. So rebuilding the tree is required. Okay, so somehow my battery died. I don't know how. It was full charged. But now when we will come back, we will rebuild the tree. Simple. Again, this is a simple thing. Do post recursion. How? Take your left and right. This will be now 3. Again, take your left and right. This will be now your 4. Now the tree is rebuilt. Now do the same thing. Repeat the process. So now this is your corresponding tree which has a rebuild. Now repeat the process. How you mean by repeat the process? Simple. Next fruit is 2. If you remembered, after fruit 4, fruit 4 is done. Fruit 4 is placed. We have a fruit 2. Okay. After fruit 4, we have fruit 2 again. We reached here. Yes, we can go. Now we will try for left first. Yes, I can try left, and when I try left, I can go left as well. Then again, I will try left. Okay, yes, I can try left and I can go left as well. Now I have reached the leaf node, which means that 2 will be placed here. If I place it here, I will simply make sure, okay, now this is placed, which means this will become -1. The root, this will become -1. And again, this will become -1, 4, 4. So this is the final value which I have, which is this specific value. And yeah, fruit 2 was placed. Now again, last fruit was fruit 5. This is the current state of the tree. I reached here. Obviously, the root value itself represents the maximum of left and right. If this itself is not If this itself is not good, not sufficient to place my fruit, obviously there's not even possibility to go anywhere left or right. If this would have been sufficient, I would have tried left first. If not, then right next. But again, as this itself is not sufficient to place my current fruit, I will have to return from here itself with a value of -1. And this is exactly what you are trying to achieve here. Although it might seem like binary search, but this is, kind of binary search which you are trying to do. Because binary search very strictly says that, the smaller will be on the left, larger will be on right. It is not exactly that. It says that I will try for the left first only because I have to go and try for a basket from left larger value. There's a possibility that you can achieve the same thing on the right side as well, right? But again, that's the entire essence of why we named it as a binary search. But again, it is not binary search. Let's see the code with the help of example as well. So firstly, we will construct the segment tree. Now, if you have any questions on this still, I'll highly recommend you have to go and watch the crash course. There's no other option if you still have a question. Now, coming on back, we realize that I will have to count the unplaced nodes. I will go on to every fruit from left to right and then start to search the location for that specific fruit. Now, this is the main search function which I actually was performing just for you guys. So I'll just do a try run as well right now, as an explanation as well. So as we saw that we do the same concept here, that try for the mid, go to the left, go to the right. So I tried for the mid, but there's a catch. We no matter what will firstly try for the left side. How we will do that? We will have a simple check that, whatever value you have on the left node, left segment tree node, if it is more than the fruit. Now, what is this k? This k is nothing but the fruit itself. So I passed in my, segment tree root node values, my left and right range, which my segment tree has to perform, and my fruit. So this is my fruit which I have passed. Okay. So this is the fruit which I have passed here. So now what will happen? I will simply check first that before going on to left or right, because now I am at one node. I have to decide which node to go to. So I will ask first that is my segment tree left node, which is, this node, is it good? Is it sufficient enough to handle the load? Which means it should be larger than my fruit. If it is, then always make sure that go to the left portion. And when I say left portion, which means 2 into n, 2 into n, and then start to mid. Right portion will be mid plus 1 to end with the same fruit value, and again the right one will be 2 into n plus 1. This is how you decide that you will go left or right. And again, you will go left, say anywhere, any which ways you go left or right, you will ultimately reach, your final destination, which will be your leaf node, which will say that leaf node says that left and right both are same. In that case, make sure that you assign the default value to your segment tree as -1, which indicates that now it is occupied and no way it can be used in future. And again, simply return your index from here. Now, what you will do here now? Obviously, you called for the search, which means you had a position. You had a position which was being impacted when you placed some fruit onto some basket. You have this position, you will simply say, okay, I can simply return this position as well. Although, for me, it's more about that was I even able to achieve or not. So again, for me, position is something I'm returning, not necessarily I would need to return it. That's completely fine because technically in this problem, I don't need to know at which position I have to place. Although if the question modifies and have a follow-up that also find me that each fruit is placed at which basket, the index of it, then this would have been required. But again, in this case, we are primarily only needing to know the unplaced or placed. So position is not required per se here, but still, just have a good thing that okay, we are returning it. Now, as I mentioned, that post recursion, while we are coming up, we again have to make sure that we are putting up the maximum because the tree or the segment tree values have now changed. That is the reason I have to make sure that I'm getting the maximum values, and ultimately I will say okay, return the corresponding position. And again, as I mentioned earlier, it is not required. Now there's one case, as if you remember, I showed you that before I go on to left or right, I have to also make sure that is it even feasible to go down, maybe at this node. So I'll have a simple check that if the segment tree node value is itself less than k, obviously there is no point of even going beyond that segment tree node because it can never return me anything. So I will simply make sure that okay, bro, you are not returning me anything. That is the reason, bro, I can simply return a value which is not possible. Now if you remember, we have to return a not possible value. So here we were returning the index wherever we were placing, and if it is not possible to place, we were returning a -1. This -1 will indicate that there was no index found. And this position, if obviously position is an index, which will be from 0 to n-1, so this will indicate, yes, the position was found. So this is the thing which I did, that on searching, if I get a -1 value, which indicated that there was no position found, and it is the reason I will increase my unplaced count. Make sure that this -1 is different from this -1, because this -1, so I'll tell you, this -1 indicates that as you are returning back, you could not find any position, any index in the basket which could actually handle your case. While this -1 indicates that now you have put up something in your basket. So for that basket value, the actual impact of the basket value will now be replaced with -1 because of non-feasibility. So I can change this value to 0 as well. And because again, we know that the corresponding basket values are more than equal to 1. But at the same time, if I change this to 0, what will happen? The position can be a 0 position as well. So this is the entire catch, which you have to make sure that there's a difference between how the code is inferred. And again, this is exactly how a simple tree traversal works. That is the reason I try to go deep into a bit of segment tree today, so that I can teach that, okay, this is a very simple code. This is a very simple tree traversal. This is a very simple, tree traversal doing a search on it, and ultimately a very simple recursion happening. So if I code with recursion, you can simply solve this assuming it's a tree problem and not a segment tree problem. Cool. Now we will have the unplaced, and then we'll simply put the unplaced count. And as we know that simple travel, like simply building up the segment tree, even doing any search of that sort, will be having O of n log n time, and space will be O of n because of segment tree being built, and also you have different corresponding constructs, your entire array and all that stuff. Cool. I hope you guys liked it. Make sure that we hit the like target of 100 likes so that it keeps the feud ongoing. And if you have any doubts in segmentary, make sure that we hit the segmentary crash course and go and watch the segmentary. Again, I have covered very depth as well, which is the range updates, which requires lazy propagation, and also a generic segmentary template as well. But in this video, I just want to show that segmentary in interviews are primarily easy, and nowadays they are asking segmentaries because it is just a reflection of a simple tree, as simple as that. Cool. Bye bye. Take care. Now I have to edit the video. Bye bye.